What would happen if we detonated a nuclear bomb on Mars? A question that might seem outlandish at first, but one that leads us down a fascinating path of discovery. Imagine the scenario. A nuclear bomb, with all its terrifying might, set off on the rugged red terrain of Mars. This isn't some sci-fi fantasy, but a hypothetical scenario that can help us understand Mars and its environment better. The impact of such an explosion would be influenced by several factors. The power of the bomb, certainly, but also the location of the detonation. Would it be on the surface or in the thin Martian atmosphere? And let's not forget the environmental conditions of Mars at the time of detonation. Each of these variables could dramatically alter the outcome of this speculative event. So let's delve into the potential impacts of a nuclear detonation on the red planet. First off, the immediate explosive impact. Imagine a nuclear bomb detonating on Mars. The explosion would release a colossal amount of energy in an instant. This energy would manifest in numerous forms, including thermal energy, shockwaves, and radiation. The intensity of the explosion would be such that it would reshape the Martian terrain near the detonation site. Picture a gargantuan crater, a scar left by the devastating blast, forever altering the landscape of the red planet. And let's not forget the Martian surface material. The force of the explosion would be so great that it could eject a massive amount of this material into the air, effectively creating a cloud of dust and debris. This ejected material would then fall back to the Martian surface, blanketing the surroundings in a layer of fallout. But that's just the immediate impact. The aftermath would be a different story. Next, we would see a spread of radiation and significant atmospheric impact. This is where things start to get really interesting and quite a bit more complex. In the wake of the nuclear explosion on Mars, a considerable amount of radiation would be released. Now here's where Mars's unique characteristics come into play. Unlike Earth with its thick protective atmosphere, Mars has a much thinner one. This means that the radiation would spread more rapidly across the Martian surface. It's a bit like tossing a handful of sand into a gusty wind rather than a gentle breeze. The sand, or in our case, radiation, would be carried further and more quickly. This rapid spread of radiation poses potential risks for future Mars exploration and settlement activities. It's like having an invisible, toxic blanket covering vast areas of the planet's surface. Not exactly the most welcoming environment for future astronauts or potential Martian settlers, right? But let's not forget about the potential atmospheric disturbances caused by a nuclear detonation. If the bomb is detonated in the Martian atmosphere, it could stir up quite a storm, both literally and figuratively. Localized temperature increases could occur, creating pockets of intense heat. There could also be changes in the atmospheric composition. This is like switching up the ingredients in a recipe. The end result could be something entirely different from what we started with. However, due to the relatively thin atmosphere of Mars, these impacts might differ from those we'd see on Earth. It's a bit like comparing the ripples created by a stone thrown into a pond versus the same stone thrown into a shallow puddle. The dynamics change, and so do the results. Radiation and atmospheric changes are major concerns, but there are more long-term effects to consider. So, as we leave the immediate aftermath of the explosion and radiation spread, we move on to the possible long-term impacts of setting off a nuclear bomb on Mars. As we'll see, these could be just as significant, if not more so. Long-term impacts could include climate change and even potential geological activity. Imagine for a moment a series of nuclear detonations on the Martian surface. Each explosion releases colossal amounts of energy, stirring up dust and debris into the thin Martian atmosphere. The immediate effects are clear: a landscape altered, a crater formed, a cloud of radiation spread. But what about the long-term effects? Let's start with climate change. In theory, if enough nuclear bombs were detonated, they could influence Mars's climate. The enormous energy released could potentially increase surface temperatures, while the dust and debris thrown into the atmosphere could trigger dust storms. These storms could, in turn, block sunlight and result in a drop in surface temperatures, leading to a sort of nuclear winter. But it's not just about temperature. The composition of Mars's atmosphere could also change. Nuclear explosions produce nitrogen and water vapor, two key ingredients for life as we know it. With enough detonations, could we perhaps create a more Earth-like atmosphere on Mars? On the flip side, we have potential geological activity. the sheer power of a nuclear explosion could trigger seismic or even volcanic activity, especially if the detonation occurs in a geologically active area. This could result in ground shaking, landslides, or even the release of underground gases. The aftermath of such events could drastically alter the Martian landscape, creating new challenges for future exploration or settlement. To sum up, the detonation of nuclear bombs on Mars could potentially lead to long-term climate change and trigger geological activity. But remember, these speculations are just that, speculations. We're still learning about Mars, its climate, its geology, and its potential for life. Our understanding of the red planet is far from complete, and there's a lot more to discover. These potential long-term changes present a whole new set of challenges, but they also open up an array of intriguing questions about our neighboring planet and our potential future on it. Lastly, let's not forget about the implications for future exploration. The radiation produced by a nuclear explosion could significantly contaminate the Martian surface. This raises a host of challenges for future exploration missions and potential Martian settlement plans. Think about it. Our rovers, landers, and future human explorers would need to navigate a potentially hazardous landscape teeming with radiation. This could damage equipment, compromise mission goals, and pose serious health risks to astronauts. Moreover, the possibility of widespread contamination could also hinder our efforts to study Mars in its natural state. We might lose the chance to uncover the planet's secrets, its geological history, potential for past life, and suitability for future human habitation. So while detonating a nuclear bomb on Mars might sound like an intriguing idea, the potential consequences are far-reaching and complex. It's a hypothetical scenario that reminds us of the delicate balance we must strike as we continue to explore the cosmos.